POE activity 1.2.7, a resistor circuit with 4 resistors. Hopefully the first relationship you can figure out is the relationship between R2 and R3 here. So I guess what we're going to do is redraw this circuit. Hopefully this works. We can redraw this circuit with the 180 volt battery and 3 resistors. R1, the combined R2 and 3, which are in parallel, and R4 stays the same, which is 5 ohms. So we got 5 ohms here, 10 ohms here, and then how do we find the, it's called equivalent resistance of these two, which are configured in parallel, to get this value here. So R1, 10 ohms. Individually, R2 and R3 are 10 ohms each. R4 is 5 ohms. So we'll call this R23. Since these two are in parallel, the parallel equation for 2 resistors in parallel is 1 over R23 equals 1 over 10 plus 1 over 10. Should be a 10. R23. Lucas, teach you how to use your calculator again. So 1 over 10 plus 1 over 10. These two 10 ohm resistors are in parallel. The equivalent resistance is not 0.2, it is 1 divided by 0.2. 5 ohms. So this essentially is one resistor that is 5 ohms. R23 equals 5 ohms from this equation here. So now that we redrew this circuit with 3 resistors, a 10 ohm, a 5 ohm, and a 5 ohm, hopefully you can know the relationship of this to get the R total down here. 80 volts. R total, when you add this up, 10 plus 5 plus 5, 20 ohms. Since you have V total and I total, or V total and R total, you can find I total. Trusty calculator. Remember, V equals IR, so that means I equals V over R. For the total column, it is 80 divided by 20. There are 4 amps. There are 4 amps in this circuit here. 4 amps. So if you look at this one circuit here, there are 4 amps going through this 10 volt resistor. And there are 4 amps going through this 5 ohm resistor, which is R4. Since you have I and since you have R, find V for the resistor 1, this column. V equals IR, V equals 4 times 10 for V1, 40 volts. And then for resistor 4, V equals IR. The resistance of resistor 4 is 5 ohms. The current through resistor 4 is also 4 amps because these are configured like this. We're just redrawing the circuit. 20 volts. So over here, you want to write down the voltage drop across 2, 3 in our redrawn circuit. In series, voltages are additive. or they change in series. So we have a 40 volt drop here, we have a 20 volt drop here. 40 plus 20 is 60. That means there are 20 volts left over for this resistor 2-3. Remember the relationship in parallel. When we split it off to parallel, if we know the voltage drop here, V2 is 20 volts. That means the voltage at 3 is also 20 volts. You can write those in here. And hopefully you can calculate I2, I3. You should also probably fill in these over here. So, that is the quick tutorial on the third resistor problem. Hopefully the page moves with it. Oh, that's pretty cool. Let's look at the fourth problem. 1, 2, 3, 4 resistors, a little different configuration. Hopefully you could figure out the relationship of these two resistors along this one shared wire. Okay, so let's redraw this circuit with 3 resistors. So I have your 12 volt battery, 40 ohm, 30 ohm, but now we got this combined resistor over here of these two. Let's call that 60 ohms because they're on the same wire. Now, this is very similar to the problem number 3, but we don't have the resistor here, so we just have to find the relationship. Of what's the relationship between these two resistors and combine them and find the R equivalent. So battery stays the same. We still have a 40 ohm resistor. This 30 ohm and 60 ohm are configured in parallel. So how do you find that R equivalent? This is where we call it REQ. So since they're in parallel, you do 1 over REQ equals 1 over 30 plus 1 over 60. They're configured in parallel. Move the calculator over here. 1 divided by 30 plus 1 divided by 60. And then your REQ is not 0.05, it is 1 divided by 0.05. That is a 20 ohm resistor. So this is where circuiting and circuits get a little more complicated. Hopefully you understand that 3 resistors, 2 that are in series, a 20 ohm and a 40 ohm, which are in parallel to a 30 ohm, is essentially one 20 ohm resistor. So let's see what you can fill out here. V total is 12 volts. I total, we don't know. R total, you could get from this redrawn simplified circuit over here. If you draw it with one resistor, R total would be this 40 plus this 20 in series, which is 60 ohms. Hopefully you know how to calculate I total. I total is, use your calculator, V equals IR, I equals V over R, which is 12 divided by 60, 0.2 amps. So now this is where it gets tricky. 0.2 amps. That's the amps going here, 0.2 amps. So because these are in series, there's 0.2 amps through the first resistor. You know the resistance of the first resistor. Hopefully you know how to use V equals IR to get that for this column. I would find this VEQ here. For this resistor, you got 20 ohm, a 20 ohm resistor in this picture, 0.2 amps flowing through it. VEQ equals IR, which is 0.2 times 20. Hopefully that gets you to the answer. So VEQ would be 4 volts. So if you put your voltmeter here, that is 4 volts. So since this one's resistor 2, the voltage here, V2, is 4 volts. And you know resistance 2 is 30 ohms. Hopefully you can calculate I2. Then we know that this voltage drop here is 4 volts with the 60 ohm resistor. So the current through this wire here let's use this one. I here, I34 is voltage over resistance, which is 4 divided by 60. .067. So there's the current flowing through this wire, which is the same as this wire, 0.67 amps. So that would be your answer to these. Oh, I'm sorry, 0.067. Should be a 0 there. Let's check our calculator. 0.067 amps. So at this juncture here, where you got 0.2 amps coming in, so much go through this wire, 0.067 goes through that wire. And you have your individual resistances here, 20 ohms, 40 ohms. Hopefully you can find the individual voltage drops across those individual resistors. Basically, this is a combination of problems 1, 2, and 3 on this activity mashed up into one advanced circuit problem. Of course, I highly recommend you using the simulator to plop this onto here.